Yeah, good evening. Atul, I call you. Good evening.
How is Ramakrishna? You are on vacation or something? How?
No. Actually, I was too. I mean, not even. Even Saturdays also we are working because of some deadlines. So that's why.
Oh, so workload is increasing.
So
Okay.
workload, yeah.
Okay.
I have one issue.
Yeah.
I have one issue.
Yeah.
Actually, we have a vessel with a. It is a partially cladded. So bottom section is cladded and upper section is non-cladded.
Mm-hmm.
So that as per NACE MR 0175, that 1% it should not exceed 1% nickel something for the copper steel.
Mm-hmm.
So now 1% nickel should not exceed 1% after welding.
Mm-hmm.
So he is saying that where the non-cladded to clad junction will be there, no. So where when we do the welding, so this will have a problem. Something that he is mentioning. So have you faced such issue, Ravi? Clad to non-clad welding.
Yeah. Actually, we done complete cladding, not partially of the equipment. So the cladding, it's complete vessel they done. So partially half and like that. No. But if you means what actually issue he is raising in there?
Is rising is that in that region where it is both the welds, I mean non-clad to clad welding, no. He's saying that where you are connecting to the carbon steel weld. In that he is saying that that nickel percentage will be more, which is not allowed as per South NACE. Actually, that this is in South Service. So that is his concern. So.
Yeah, that's why I think whatever vessels we worked, they clad. Partially they will not clad. But I don't know why in your case it's there partially they're cladding.
For the economy, no. It is only up to as per the client requirement. It will be that south region will come only up to certain height. The remaining to save the cost.
Then you can increase a little bit of that height because whatever the welding is saying, so you can make the yeah.
Then like that means we have to completely do that. Complete vessel we need to do this part, no.
Yeah, complete vessel, but his concern is with welding, no? Welding which are you are welding only
wherever, whether it is here or there, wherever this clad to non-clad welding joint will come, there he is not acceptable. Something is telling that nickel percent will be more. So something.
No, nickel percent is more means if you are using the nickel percent more welding rod, you use nickel percent less content welding rod, then it will be matches.
Yeah. Correct. I also didn't clearly understood our QC is reviewing. So.
Okay, check with that.
Have you faced any?
Yeah.
Have you faced?
We did one model exchanger which was half overlay with LTS. And so we did 50 mm plus overlay to the junction and did the welding.
Oh, okay. Meaning, for on that first you done the overlay for the after welding, you grind it and then again you put the overlay. Okay.
Yes.
Okay. And after the joint around 50 mm.
If my requirement is half there, we did overlay to the 50 mm plus, and we welded to the 50 mm plus portion. So then my complete requirement is fulfilled.
Okay. I think it seems to be a good idea.
Then this overlay, whatever you done, then again you are using some welding rod, but with that welding rod should be again the nickel content should be less, right? As required by your client. So when you do that one,
but
because
sometimes we cannot control the negative.
yeah. So your consent means Ramakrishna, your consent, client consent is nickel content in the welding. So even if you even if you initially if you weld and again after on that one if you this overlay if you do the cladding and that one, then again the welding will be there, no, always.
Still better. This time, this welding will not come in that junction, no. So I think.
Yeah, that metal,
we-
metal contact, but
Yeah.
metal contact and this overlay will not. It's means avoids the connection, direct
Welding will
connection.
not be there. Only overlay will come.
Yeah,
Overlay will come.
overlay will come.
I think this seems to be good idea. Okay.
Okay, try.
I will try. We'll discuss with the QC. I think it seems to be okay. Thanks, sir.
Okay. Okay, you got. Okay. Next, you have any more?
I also want to ask, I want to also
Yeah.
another question. If I want to do the perforated basket stress analysis, means the calculations of the perforated basket, which have only 0.2 mm holes, 0.3 mm holes like that. Now the case is that whenever I'm doing filtration with the perforated basket, that perforated basket is bulging from inside, which has only 0.2 mm holes. So how can we design the perforated baskets for any kind of internal pressure, vacuum pressures, if any answers?
Anybody want
Perforated
to?
baskets
Yeah. Anybody want to
with
answer?
200 microns, with 300 microns, like that.
No, you mean to say design means? Are you talking about the perforated sheets are in a plain sheet or it is in a curvy sheet?
In the curve sheet, sir, we manufacture, we rolled it and weld it.
Okay, so the curve sheet
200
normally,
micron.
so the curve sheet normally designed to take the pressure, but how much curve is to be done to handle that pressure, that I'm not sure how to calculate, because that is again it is something like the manufacturer of that sheet who decide like how much curve or the wave they provide, right, in the perforated sheet, so that they decide on the basis of either some calculation or as per their experience.
The example is sieves, sir. Sieves are, okay. If we apply the vacuum on the sieves, at what pressure sieves will get bulged? How can we design it?
Not sure on that.
Okay, Atul, you want to add something? Okay. Okay, Kamish. I think it's similar to this our heat exchanger tube sheet, no? What are the holes you are mentioning?
Yes.
It's again it's a non-metallic US one.
No, metallic, sir. You know about the mesh. I'm talking about the mesh sieves.
Yeah,
Okay,
but
that is your infiltration.
yeah, this again this if metallic and that one it's similar to heat exchanger there where the tubes are there where tube sheet having the holes in that one. So similarly you can find that one the verification of that one, the how much holes whatever provided, whether this the thickness whatever provided for that plates and that one, whether it stand with that pressure or not. But in your case I think
No, Ravi, that is not actually the tube sheet, because this is something like only the filtration. There is no support of tubes. Okay. So
Yes.
it is like it is just like a filter with number of holes. Now in the filter, they normally create a wavy surface. You know that is we call perforated. Like it's not the straight surface. So that perforated sheet itself, I mean to say, the wavy structure is designed to take the load, and the load is not that much. It's like a weight of the fluid.
Solid. Weight of the solid.
Solid or fluid, yeah, whatever. So that load only it will take. So it's not like pressure or something like 2 bar, 3 bar. So that way, I'm not sure how the manufacturer of those perforated sheet normally it is like just like internals provided by the vendor. So vendor normally decide how
Yep.
it should be. So how they calculate, I'm not
yeah,
sure
but
about
the
that.
weight whatever the loads coming on that one, like as you said, the liquid or maybe the solid, whatever the it's filtering on that one. So the loads, how much loads it's coming? I think it's
Full vacuum, sir. Consider full vacuum from inside.
no, inside vacuum, but that vacuum will not act on that one, no? It's just the whatever the Kaushik has said, some maybe the liquid or maybe the fluid or maybe the solid which laying on that perforated sheet. That weight only need to be considered, no?
Yes, but there are some recipes to operate that filter. In that we have to apply the vacuum from the inside. So there is a must necessary that basket should be withstand with vacuum. And when we apply the vacuum, that basket is bulging from inside. And for in FAF, we cannot calculate the FAF of the perforated basket because computational time is too much required because to formulating the total perforated basket, there are only 0.2 mm, 0.3 mm holes in basket that are of in number of 20,000, 25,000. It's not possible to computer to calculate that FA. So this is a very tough job to design any perforated basket.
Yeah, but actually you have to means my understanding. It's just you're thinking it is a complicated, but as Kaushik said, it's just the carrying the liquid or solid which is need to be cleared from that hole, perforated holes. So
Yes.
the vacuum and that one, I think it's not applicable on that basket. The vacuum will applicable on the walls on which this basket is fitting, right?
No, sir. Actually, this is the not a perforated basket means what? This is only 0.2 mm holes. Sir. There are normally perforated basket which are using in bag filters or that have 3 mm holes.
Yeah, but this
They have not
perforated
found.
basket, whether it is fitting on some wall or it's only you have the perforated basket.
Flange, it's fitting on flange by bolting.
Yeah, flange it's fitting on the flange plus on surrounding there is some wall around this basket.
Yes.
Around there is
Yes.
yeah, wall is
Yes,
there.
yes.
No? So if there is a wall is there, then whatever the loads or pressure or vacuum what is coming, that's coming on the wall. It's not on the basket because something if you are placing inside this means vessel is there. On vessel whatever the internals are there, maybe you have some pipe, you have some boltings, you have some trays holding this basket, holding some fittings are there. Thus pressure will not act on that one. Pressure will act only the walls where your vacuum is creating. Means if you see our PVRate calculation also, whatever the pressure inside or outside what we are doing, it's only the applicable on the walls of that vessel. It's not applicable the internals whatever we have provided, right, Atul or Kaushik?
Yes, correct.
Yeah. So it's yeah. So it's applicable only in the walls. So whatever internals you are placing inside, it's just as a some dummy. It means it's the pressure is not applicable, but the whatever the weight is coming means you are maybe a liquid is passing from that basket, or maybe the some solids. Fine solids are passing from that basket. Thus weight you need to consider on that basket because this is load which holding that basket rather than that of any vacuum or any pressure inside. Right, Kaushik?
Yeah, correct. But Kamesh, what you need to do this discussion, you have to share some photos. Otherwise, our imagination, it's like we cannot imagine lots of things, right? So if you can share some photos, it will be more clearer what you want to say. Maybe your design is something different, whatever we are imagining.
Yeah, you have any photos, Kamlesh, with you? No, you can. If you have, you can share so we can see and we can.
Yeah, I will draw the picture. I'm presenting the screen.
Yeah, draw. Okay, if you have any ready-made, you can share. Just crop the only the which you want to show that much.
No, I have not tried now. It is in my company.
Okay, okay,
So okay, now.
okay.
So from this is the inlet, and here is outlet. Okay.
Okay,
Here is ceiling. Okay.
okay,
Here is a top down, bottom down. Here is the outlet. Here is another drain nozzle. So when we doing filtration, this is a metallic basket, not a bag. Okay. okay,
Okay.
which has only 0.2 mm hole.
Okay.
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 Now when we are doing solid pass, the filtration is doing. Now there is a cake here. Okay. This is a cake. Now.
What is that one? Red one?
Yes.
Yeah, red
Hello?
one. What it is? Red one?
Yes, red one is solid.
Okay, solid surface. Okay.
Okay.
Mhm.
So this will totally filled with the
Okay.
cake
Mhm.
after filtration. Okay.
Okay.
Now this is this plant is not like this. This is like this. Okay. Sorry, this like this. Okay.
Okay.
Now we have to drop this cake at bottom. Okay.
Okay.
So we are doing here nitrogen.
Mhm.
So when we are applying the nitrogen, some cake drops, but some is sticking to this
Wall of that one.
wall.
Okay.
Now we have to remove it.
Mhm.
Okay.
Okay.
Then what we do? We apply vacuum from here.
Mhm.
Okay.
Mhm.
Reverse vacuum.
Mhm.
So this cake get reverse. The cake will stick to this basket.
Mhm.
It's will remove with the help of basket, with the help of vacuum. Okay, because it is stick with the basket. We are applying the vacuum to remove that cake, which is stick with basket. When we apply the vacuum, that time this basket it's getting outside color, means like this. Like this shape,
Mhm.
bulging from inside. When we are applying the vacuum from here, top load.
Okay. Okay. So now I think we got right. So you are applying vacuum to the filter. It's not the vessel,
Yes,
right?
yes, yes, yes.
Okay. So the same way what we used to do for vessel, I think anybody want to answer or? Okay, the same way which we used to do for the vessel. Vessel, what we'll do, the complete in designing, we consider that as a complete as a solid vessel, and that solid plate is applying the whatever the vacuum or maybe the internal pressure. So in your case, you have to apply the vacuum. So considering the thickness of whatever the filter you provided, consider that one as a complete hole, not the whole one inside the you whatever the perforated holes you have. You don't consider that one. Complete consider as a full as a metallic one, means full as a complete as a solid, and apply the vacuum in that one, and verify that one whether it will withstand with that one or not, and accordingly you can resize the whatever thickness you selected for that one.
But sir, that is a solid shell.
Yeah, don't consider this as a perforated, consider as a solid, and apply the vacuum.
Sir, yes, we are doing with the help of that only, but that are not working correctly. So the basket is bulging.
Not working means
if
maybe
basket is okay. Just Ravi, just if basket is bulging, I think you should provide some external stiffener. Okay.
Yes, we have provided it also.
Okay. So if you provide external stiffener with a sheet, maybe the sheet size is in mm, right? 0.2 mm or 0.1 mm. I'm not sure what is the size of that sheet. So if you provide stiffener from outside and then you apply the vacuum, means that is the external pressure, right, from that basket. You are putting external pressure. Maybe if whatever vacuum, the equivalent amount of external pressure you are putting on the basket. So that external pressure it should withstand with providing that stiffener, and I believe it should work if you provide the stiffener maybe by increasing or reducing like permutation combination, then your FEA should not I mean to say then it will not show bulging. Maybe some stress will be higher side on the area of that stiffener. That can happen.
In FEA, I cannot calculate because of there are two. This is the biggest geometry because of lot of holes in the
No, don't
basket.
consider that holes.
Don't consider the hole, because actually what is happening actual case, when are you applying vacuum, at that time it is the hole, all holes are already blocked. Okay, so the sheet at some fraction of time it is considered as a sheet only. If hole is there, then it will not bulge from the hole. The vacuum will not be created, right? So at the time when vacuum is created, that time it is like full of the holes are blocked. So it's like a sheet. So you consider as a sheet. Then
But I cannot consider it as a sheet because that one in hole there is solvent.
Yeah, hole is there, but again, you are the water, the solids, it's fitting in that one, that holes. And when you are putting the
Because
vacuum, it
in FEA there is a mesh to mesh bonding. We are considering solid tetrahedron elements.
yeah,
like
correct. So what happens now? Suppose what you can do that to check exact the what is the nearby condition. So when you consider the sheet, suppose the sheet size is example 1 mm. Okay, so you have the area, okay, the volume, and then you consider the density, and then you take the mass of that sheet. Okay, now you putting holes, so you are removing materials, right? So what will happen? Whatever materials you are removing, equivalent to that, the sheet size will reduce. You got my point?
Yes, I know.
Yeah. So sheet size is reduced. So then you have to consider a sheet which is the suppose you are taking 1 mm sheet, but when you putting holes, there are so many materials you are removing. So maybe you have to consider 0.5 mm sheet. Then the mesh, whatever it is considered in your FEA, like number of meshes. So it is taking the weakest link now, right? Weakest part. That you reduce the thickness, right? 1 mm to 0.5 mm. If 0.5 mm can be sustainable, that means after taking the material is equivalent size is 0.5 mm, then 1 mm also will sustain. So that is one. I'm not telling that this is the one criteria. There may be 100 criteria you have to evaluate, but one criteria is that in the FEA that you consider like that and check if it is working or not. Then maybe other criteria also you have to put.
that stiffness is to be it's circular. You are providing only at the corners, or it's a complete the filter surrounded with
surrounded, completely surrounded.
okay, so even you can increase that one the means width.
No, there is a filtration drop. There is also that we don't want.
Like in our vessel, we used to provide as a ring type. We used to provide like that. Also, you can provide the complete ring type, the stiffness to that one, thickness, and that one you can increase that one. So accordingly, it will be. So try that. What Kaushik said, that one or two different options, providing a ring size, the stiffness size, increase that one, or thickness of that filter you can increase, and considering as a solid, not as a your perforated. Okay.
I'm doing also the flow simulation for this kind of job like that. If I am passing the water from this, okay, then what is my pressure drop to this side and this side? With the help of flow simulation, I am also calculating it. Only for your knowledge, I am telling.
Pressure drop and that one again, it comes to not mechanical, it comes to process.
I can do the calculation of the flow simulation also. If anyone required in future, I can provide it.
Okay, that's a good one. But currently, I think you have to concentrate on the what your Kaushik said or what your suggested.
Yes. Thank you.
Okay, you got. Okay, any other issue you want to discuss? Okay, Mohit, how many tanks you are handling now?
Sir, actually, 2 tanks are there.
2 tanks. Okay, and this both are 35-meter diameter?
No, the second one is of 55 meter.
It's a bigger one.
Yes, and there we have provided 2 roof drainage system with 2 NRVs in the sump.
Okay, there also 2 NRVs. And what is the size of sump you consider in there?
Diameter is of 1.2 meter.
1.2. Okay, and that you arrived by how you arrived at 1.2?
Actually, sir, there were some drawings given to us by LNT. Okay. So, by considering that and installing the NRVs, we have like taken the dimensions after giving the clearance.
Okay, okay. So they didn't provide any standards to you for this, some standards or something?
No, no, sir. Even they are doing it by the engineering judgment and past experience. That is the main problem.
Okay, if
They could,
if I that names and that the handbooks and that one I will share to you, and
yeah,
maybe in the
sure.
group I will share. And if I find any standards also, that also I will share to you, because that whatever I shared you, that's also from some other projects I shared with. This is the normally what we'll do with that clearance, and that one we'll consider, and accordingly we'll go that one.
Okay, sir.
But only the main consideration is the drain should be passed within the specified time, that from the roof to the bottom. Like that we need to consider. So this tank complete designing you are doing by manual, or how you are doing?
Actually, tank has been designed by LNT. We are doing the roof drainage system.
Okay, only you are doing the roof drainage system, only that's all?
Yes, yes, sir.
Okay, not complete tank design.
No, no.
Okay. Did you done any tank designs of that one?
No, sir.
Okay. Okay, it's very interesting if you go for tank designing that one. In the roof floating on that liquid, you have to calculate that one, plus you have to the whatever that when it's this roof comes down, then how it will be stands, that also you need to calculate, and any gases which flows, that need to many good check if they can provide you the calculation what they done, so it will be helpful for you. Did you done any previously any calculation for tanks and that one?
No, sir. Actually, I have done calculations for the air cooling exchangers in the past.
Okay. So tank also it's a good it's one good knowledge. I mean you'll get good knowledge or good exposure if you come to across any of the tank designing that one. Try that one. It'll provide to you. It's well and good. Otherwise you can get on net also. There are many tank calculation you can find on the net.
Question was how the drill pattern will be created automatically, whether he has done it or not. That was the Kaushik. One more. My question is now it is vessels, vertical, horizontal.
Anything you can make. The thing is that we are now slowly progressing like equipment by equipment. Okay, actually we can do means in our pipeline there are lots of things to be done. So it was just like how to do one by one. Like as you know, there are so many things to be considered, and it is not. It's frankly speaking, if you say the equipment, it's infinite, because every company having their own template, and some companies, you say the end user or you say consultant, they have their own system like drawings, like supports. All times it will changes. So that's why we will not say it's like it's incomplete, maybe another, I don't know, it's infinite, but it is like every time its learning process is going on. So it is every time it's going to improve. So maybe if you see next maybe couple of months.
Kaushik, Kaushik, my next thing is it can provide the, at least for heat exchangers, it can do the fully.
Heat exchangers, the type, again I'll say there are actually 13 types, here it is covered. Okay, the major common one like AES, BES, okay, so then these, there's 13 types, it is covered. So 13 types you can generate. Okay, now we have some custom, suppose you want to do some custom, that also you can do. So maybe you will do by changing something in the model. So that is up to you how you do the custom things. So here actually the intention is
we require intergraph. This intergraph as Inventor as a base software, right?
Yeah, paid software.
Inventor and also you SolidWorks, no? It's both you will take.
No, actually this is a platform. Inventor or SolidWorks is a platform. So if you buy a Inventor, you will not get it. Okay, so how actually it works? Normally,
I understand Kaushik. I understand that. It is like a macro. Okay, I understand that. So whether it is for, it works with any software or only for
as of now it is only whatever you've seen. It works with Inventor only.
He has to buy Inventor or just your software is enough to do?
No, we normally how our system works. Okay, we don't sell the software. So what will there? It's like a collaboration. Suppose a company X wants to have use this automation. Okay, so it is like a collaboration. So they will have the collaboration with us. Then they will get the access. So they will generate the drawings. And it is like a both way will work. Like sometimes, as I said, it's like unlimited work. Like some custom things will come. Maybe that time he has to generate the model or some parts manually. So that also will help. That's like an end-to-end software. So you buy a software, run it, not like that. So it's something like collaboration.
So if we take your software, then those models are there already, right? Heat exchanger, whatever 13 types you told, it is already there. So if ours is the same, any one of the type of that one in that 13, so we can directly generate the drawings with that.
Correct. Yeah. You can directly generate the drawing.
Okay, Ramakrishna. I think if you have the same type, then we can use. Otherwise, we custom. We have to inform him, or we can make some changes in the existing if we require some other.
Yeah, but actually, what happens, when any company want to buy, so they want to have a flexible kind of not only protection. They'll expect to do follow-up and all. It's like that. And I think, as Kaushik said, still it is an ongoing process.
Yeah. As he is saying that, Kaushik, there are infinite numbers of equipments. So he is now concentrating on heat exchanger. But for us, we require anytime any equipment may come. So we have to be ready for that.
Everything will come.
Yeah, we have to be ready for that.
We have to justify it to management to buy.
Yeah.
Like that.
Okay. Also, you told that you will provide some product also, no? So your product.
So this is the product. I mean to say this is the product, but you will not get the product as a PB light. You will get the product in the server.
Okay. So it will be loaded in the server. So Atul has to maybe take some.
Yeah, Atul has to use it, create drawings, do some modification, whatever he wants, because that's a platform.
So he has to take some subscription for that one.
Yes.
Means buying inventor is not necessary, no? When it is server on the server.
Nothing is necessary. Nothing is necessary. You have to just pay monthly subscription. That's it. You have to do on the work as you want. So inventor is included on that. It's a platform, right? Suppose you are using actually two things here. One is the platform, inventor platform. Another is the internal program with the inventor. Okay. So suppose you want to do you don't want to do that heat exchangers. Maybe you want to do something else. You want to do something else which is different for the 13 types. Okay. You want to create something like pipe, some flange, something. So you can create it. It's your platform. So that is no restriction on it.
How much time, as I am good knowledge in heat exchanger and all 13 types I'm familiar with it, and how much time I will take to design it after the all inputs knowing.
See, that question is as Ramakrishna told once, like we also discussed that. It is not telling you that time, okay? It's telling you your speed.
Yeah, my speed is pretty good.
Yeah, so you mean to say you want to how much time, because the time is actually depends on the human to human. So there is no, so as you have seen, right, the how much time it is taking to generate. Okay, now suppose you want to create some part, new part. Okay, that new part will take you time to create it, maybe 5 to 7 minutes or 10 minutes or half an hour. Okay, so now those things you have to include. So suppose the heat exchangers, if you say me the 13 types, I will say to create a model it's 1 day and then GA finish. You will explore something new on that. Okay, you want to add some lifting lug. So maybe that lifting lug you have to design again. That lifting lug is not available in the database. Okay, so you have to create that. So that way it is like, it is not, I am not telling it is very much faster, but yes, you are, I am telling you it's a different, altogether it's a different. How much speed you can generate on that, it's up to you.
But only GAD and 2 bundle scale, nothing else.
Yeah, so you can generate. See, the difference here I am telling you, it's like my practical experience I am telling you. When I was working in the AutoCAD, that time I didn't have anything experience on AutoCAD, okay? I didn't know AutoCAD, frankly speaking, and the way the draftsmen are doing very fast, okay? Then what happens actually when we design, as we say, we are, as an engineer, we are not actually a skilled person, okay? We are like simply you can say it's a coordinator, everything. PV light is giving the calculation, we are doing the calculation. So PV light is doing the iteration, so we are simply changing the data. We have some exposure on ASME, which draftsman doesn't have. But draftsman having their skill, I mean to say they do it faster, they do, but we don't have anything on that. So what happens, anything to change now, I had to go to the draftsman to tell, okay, you change it. Now the tube arrangement is got changed. Now what happens here, you have that authority to do the changes by your own and do the experiment. You got my point? So draftsman side, when you want to do some experiment, suppose it's PV light, you are changing so many iterations and you want to do it, your management will not allow you to do those changes, because it will, every time you are giving some input to the draftsman and draftsman is telling you he is changing everything every time, every 2 hours, 3 hours he is changing. So now you can do that. So what you are giving to the draftsman a final product, after your full experiment, you are giving a final product to make the drawings. So now what the draftsman is doing, draftsman is taking those model, 3D model, and he extracting like from there, giving the dimensions, giving the annotation, creating the BOM, arranging that BOM, maybe some arrangement like number 1 what you want, number 2 what you want, like that. So those are like mostly it's like some adjustment on the style. So that you can measure like a draftsman how much time he should take, or you can allow that much of time to make the drawing as a fabrication drawing. But you see now how much experiment you as a individual can do, or the third guy or the fourth guy, they can do those things. Before it was like input output checking. Now your checking time, you see the BOM, it is generated whatever you generate in the model, right? So now it is not like you have to check the part number with the BOM matching or not. It will match because definitely it is coming from the programming, right? You have to check once, if it is matching, means it will match with the parts. So every time you no need to check, and it is taking those timing actually management doesn't care, it's your pain. Because I understand, I came from that field, that's why I understand. It's your management don't understand that. Management think about as a team, right? You, draftsman, all are in a team. Someone structural guy. So they don't think about these leakages. These are called leakages, small leakages, which you take the print, you check it, you go to the draftsman, right? These are time-taking job. So those are never considered as you can say as a leakages. But if you understand this, then you will say, okay, it will really save time. But as a management, then management will see, okay, I am paying 4 or 5 people, right? So for them as a management, maybe it will not change suddenly. But you think about maybe another 1 year when all are equipped with that software, the way of work you are changed. Then maybe you're changing your creating of drawing, it will take 2 days, you will finish it.
Yeah, absolutely.
Okay. You got your answer?
I will.
Okay. Any more?
no, nothing from my side.
Okay, Ramakrishna, do you have anything?
From my side, nothing. Yeah.
Hey, Kaushik, can we wind up?
Yes, I think it is already 4:09.
Yeah.
Yeah. Okay.
Okay then.
Okay, thank you.
Good night.
Thank you.
Thank you, Kaushik.
Thank you.
Thank you.
Bye.
Bye.
Thank you. Thank you.
Thank you.